Hello everyone and welcome to this presentation on firewalls. This is anti-network security. We are continuing from where we left. From network security, we explained intrusion detection systems and prevention systems. We explained secure protocols, and we also explained the VPNs, virtual private networks, and now we're on firewalls under network security. So today we are focusing on firewalls, the types of firewalls, what is a firewall, the importance, and how a firewall works. So by definition, a firewall is a security device or software that acts as a barrier between a trusted internal network and an untrusted external network, such as the internet. So we are saying that this is a set of related programs located in the network gateway server that protects the resources of a private network from users on another network. So a set of tools that monitors the flow of traffic between networks. So it filters incoming and outgoing traffic, right? So its main function is to monitor and control incoming and outgoing network traffic based on a predetermined security rules. For example, a company might use a firewall to block all incoming traffic from unknown sources while allowing employees to access the internet freely. So a firewall is typically placed at the network level, often working closely with the router. So it filters all network packets, deciding whether to forward them towards their destination or block them based on the rules set by the network administrator. So this setup ensures that only legitimate traffic is allowed into or out of the network. So firewalls are often installed away from the main network infrastructure so that no incoming request can directly reach private network resources, right? So if configured properly, systems on one side of the firewall are protected from systems on the other side, providing a strong layer of defense against external threats, right? So here there is a point that is there in our slides. That's the Great Worm of 1988. This one, to understand why firewalls are so important, we also need to look at the historic incident of this. The modest worm of 1988, this was one of the earliest computer worms to spread across the internet, written by a graduate student named Robert Chapman Morris. So the worm was launched from the Massachusetts Institute of Technology and was quickly infected thousands of computers, causing widespread disruption. So the modest worm exploited vulnerabilities in network services that were not protected by firewalls or other security measures. So its rapid spread highlighted the urgent need for better network security and led to the first felon conviction under the US Computer Fraud and Abuse Act. So this event made organizations realize that they needed mechanisms such as the firewalls that we're going to explain this in this presentation to protect their networks from such attacks. So a firewall, right, when placed at the network level and working closely with the router, filters all network packets to determine whether or not to forward them towards their destination. So by doing so, it acts as a gatekeeper, ensuring that only authorized traffic can enter or leave the network. So these are often installed away from the rest of the network, specifically to prevent any incoming request from reaching private network resources directly. So this strategic placement is crucial for isolating sensitive systems from potential attackers. So if this firewall is configured properly, all systems on one side are protected, right, from those on the other side, right? So that's on the security private local area network that we're seeing on the diagram, and then the public network, right? So this means that even if an attacker gains access to the external network, they cannot reach internal systems unless the firewall rules explicitly allows it, right? So let me break down how a firewall operates beyond just to what you are seeing here, right? Before we move on, I'll read what's on the slide. So, a firewall is an intrusion detection mechanism and are specific to an organization's security policy. Firewalls can be configured to restrict incoming traffic, to POP and SNMP, and to enable email access. So, firewalls can be configured to check inbound traffic at a point called the choke point, where security audit is performed. So, the firewall can also act as an active phone tap tool in identifying the intruder's attempt to dial into the modules within the network that is secured by firewall. So the firewall logs consist of logging information that reports to the administrator on all the attempts of various incoming services. So the firewall verifies the incoming and outgoing traffic against the firewall rules. It acts as a router to move data between networks. Firewalls manage access to private networks, private networks to host applications, and all the attempts to log into the network are identified for auditing. So unauthorized attempts can be identified by embedding an alarm that is triggered when an unauthorized user attempts to log in. So firewalls can filter packets based on address and types of traffic. Before we move on to the types, I need to explain something. So, how the firewall rules. I want to explain firewall operations. So, one, they are what we call firewall rules. The firewall checks all incoming and outgoing traffic against a set of rules defined by the administrator. So, these rules specify what kind of traffic is allowed or blocked based on factors like IP address, port number, or protocol. Then it acts as a router. In addition to filtering traffic, the firewall can act as a router, moving data between different networks. So this means it not only blocks unwanted traffic, but also ensures that legitimate data reaches its intended destination. Then there is also what we call the managing access. Firewalls control which users or device can access private network resources or host application, preventing unauthorized access. Then there is auditing login attempts. Every attempt to log into the network is logged for auditing purposes. This helps administrators check who is trying to access the network and identify any suspicious activity. Alarms for unauthorized access. Firewalls can be configured to trigger alarms if someone tries to log in without authorization. This immediate alert allows administrators to respond quickly to potential threats. Then there is what we call packet filtering. Firewalls can filter packets based on their source or destination address, as well as the type of traffic, such as web browsing, email, or file transfers. So now we need to move on to the types of firewalls that we have. And here we have packet filters, we have circuit level gateways, we have stateful multi-layer inspection firewalls, and then we have application level gateway. Then when we look at the packet filtering, on the diagram, this is the most basic type of firewall. So it examines each packet of data, right, that passes through the network and accepts or rejects it based on user-defined rules. For instance, it can block all traffic, maybe from a specific IP address, or only allow web traffic, maybe on port 8. Packet filtering is fast and efficient, but offers limited protection, as it does not inspect the contents of the packets. So, a router can be configured to block all incoming traffic except for HTTP and HTTPS, right? So this one, this is shown in the diagram, works at the IP layer, right? So it investigates each individual packet passing through it and makes a decision whether to pass or to drop, right? So packet filter based firewalls concentrate on individual packets and analyze the header information and which way they are directed. So these are make decision based on the following information. The information is given on the screen: the source IP address, the destination IP address, the source TCP or UDP port, the destination TCP or UDP port, the TCP code bits, protocol in use, direction, and then the interface. Then we move on to security level gateway firewall. This type of firewall works at the session layer, right, of the OC model, or the TCP layer of TCP IP. This type of firewall monitors the TCP handshakes and other session initiation messages to ensure that the session is legitimate. So once a connection is established, it allows packets to flow freely without further inspection. Right. Example, we can talk of a source proxy servers which verify the legitimacy of a connection before allowing data to pass. Right. So it forwards data between the networks without verifying it. So it blocks incoming packets into the host but allows the traffic to pass through itself. So information passed to remote computers through security level gateway appears to have originated from the gateway, as the incoming traffic carries the IP address of the proxy. Right. So we need to move on to the application level firewall. This one, also known as the proxy firewalls, right, operates at the application layer. They inspect the actual content of the traffic and can block specific content or applications, such as preventing users from accessing certain websites or downloading files with specific extensions. So these firewalls provide more granular control but can be slower due to the deeper inspection, right? So an example is a web proxy that filters out malicious websites or blocks access to social media, right? So these firewalls analyze the application information to make decisions about whether or not to transmit the packets, right? A content catching process optimizes performance by catching frequently accessed information instead of sending new requests for the same old data to the servers. Then we'll move on to the stateful mode layer inspection. These ones track the state, right, of active connections and make decisions based on the content of the traffic, not just individual packets. They combine the features of packet filtering and application level firewalls, providing a balance between security and performance. And most modern enterprise firewalls, which can remember the state of connections and only allow responses to legitimate requests initiated from inside the network, right? So this one provides the best of both packet filtering and application based filtering. These firewalls tracks and log slots or transactions, right? So they filter packets at the network layer to determine whether session packets are legitimate, and they evaluate the contents of packets at the application layer. We also need we move on to firewall identification techniques. Attackers and security professionals use several techniques to identify firewalls and their configurations. Then there is a port scanning, and on top of port scanning involves sending requests to a range of ports on a target system to discover which ports are open, closed, or filtered by a firewall. For example, an attacker might scan all 65,535 ports on a server to see which services are accessible. If most ports are closed or filtered, it indicates the presence of a firewall, right? So open ports can be further probed to identify the version of services which help in finding vulnerabilities in these services, right? There are some firewalls who uniquely identify themselves in response to simple port scans. Now, talking of ACLs, these are access control lists. These are a set of rules that define which packets of data are allowed to pass through a network device, such as a firewall or a router. So ACLs are used to filter incoming and outgoing network traffic based on parameters such as source and destination IP address, the ports and protocols, such as the TCP, UDP, ICMP, then the packet type and content. So Firewalk is the most well-known software, right, used for firewalking. It has two phases. It has a network discovery stage, and in this stage, Firewall sends the packets to the target network to discover the network's topology and the identity of the firewall, and to identify maybe the firewall or packet filtering router, then and a scanning phase. And this one, once the network topology is known, Firewall sends specially crafted packets to the target network to probe the ACLs on the firewall or packet filtering router. So this helps to determine which ports or protocols are allowed or blocked. It requires 3 hosts, right? This one. So he explained firewall identification and firewalking. Now we will move on to. Before we move, we explained that firewall is a technique used to determine which ports or protocols or firewall allows through. So it works by sending packets with a gradually increasing time to leave value and analyzing the response. By observing which packets make it through and which are blocked, the tester can map out the firewall rules, right? So an attacker may use firewalking to discover that a firewall allows DNS and web traffic but blocks everything else, right? We move on to banner grabbing, and when you are talking of banner grabbing, is this one this process of connecting to a network service, right, and reading the welcome message or banner the service sends back. So this banner often reveals information about the software and the version running on the server, which can help identify vulnerabilities. Banners are messages sent out by network services during the connection to the services, and the banners announce which service is running on the system. So banner grabbing now is a technique generally used by the attacker for OS detection. So the attacker uses banner grabbing to discover services run by firewalls. So the 3 main services that send out banners are FTP, Telnet, and web servers, right? Right. So this marks the end of our presentation. So in conclusion, firewalls are essential components of network security, acting as gatekeepers that control the flow of traffic between the trusted and untrusted networks. So they come in various forms, each with specific strength and weakness, play a critical role in protecting systems from threats like the malware that we explained, and understanding how firewalls works, the different types are available, and how attackers identify and probe them is crucial for building and maintaining secure networks. Thank you for listening to the presentation.